Hello everyone, you are welcome to the GMAT 41's Organic Chemistry class. Today I'll be teaching you IUPAC Nomenclature of alkynes. You would recall that in our previous class I taught you how to go about the IUPAC Nomenclature of alkenes. Of course, towards the end of the class, I stated that everything you've learned on alkenes, alright, applies to when you are treating alkynes. I guess the only difference would be in the way we handle the suffix YNES as to how we handle the suffix in alkenes ENES. So what do I mean by that? As alkenes ends with ENES, that is alkenes, ines. For alkynes, it ends with what? YNES, that is ines. As to that principle I taught you in our previous class, splitting the prefix from the suffix and indicating the carbon atom bearing the unsaturated bond. That's the double bond in the case of alkene, and here now triple bond. That same principle applies to alkynes. And so it's going to be a wonderful class. We're going to kill it, okay? Because we wouldn't waste much time talking about all those full analysis and other stuff. I want to believe that you have been able to do justice to alkenes. And that being the case, this is going to be an enjoyable class as usual. And so now I'm welcoming you as we look at our very first structure, number 1. And so looking at this first structure, we can determine the longest carbon chain. But first, we need to identify that this is an alkyne. And how did we know that it's an alkyne? The triple bond we have here. The functional group of alkynes is triple bond. And so that is how we get to know that this compound is an alkyne. And of course, when you are trying to get the longest carbon chain, which is the next thing you check, you must count to include all the triple bond you have in the structure. In this case, we have this one triple bond. So finding the longest carbon chain, I can check for this straight chain. I can check for this branched chain to find out which one is longer. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I guess we have 6 carbon atoms as the longest carbon chain here. When we treated alkanes and alkenes, I told you something that if the longest chain gives us equal number of carbon as any branched chain, I'll prefer taking the straight chain as the longest chain and then treat that branch as an attachment. That is what I like doing. I've said this before now. But this time around, I'll just like to do something else. I'd like to take this branch as the longest and treat the others as attachment. Like I stated in previous classes, you will still get the same name even though you decide to take the straight chain as the parent chain. So in this case, I like to take this. And then looking at the structure, counting will start from this side because the triple bond is closest to this end than it is if I start from here. Are you following, right? Going from this side, the triple bond is on this second carbon atom. This is carbon atom number 2. But if I count from this direction, are you following, right? It would be on carbon number 4. Because this will be 1, 2, 3, 4. After the 4th carbon, you see the triple bond. But counting from here, 1, 2. After the second carbon atom, you see the triple bond. So the lowest sum is that from this end, going this way. Alright, let's move on. Having said this, you observe that on this 4th carbon atom, this is the 4th carbon atom, you have this as an attachment. It's a substituent because I did not count it among the parent chain. This one is also what? A substituent because I did not count it among the parent chain. This last carbon is the 6th carbon. So we have 6 carbons here. Because the parent chain has 6 carbon atoms, it means that this is going to be hex. That's the prefix. Remember, 6 carbon atom has the prefix hex. And then, since the triple bond is on the second carbon atom, then we're going to say 2, and then we'll conclude with what? Ine. Hex 2-ine. That's the name of the parent. But of course, before we talk about the parent name, you know that we need to identify the attachments and mention them. Here, on the 4th carbon atom, we have this methyl attachment. On that same fourth carbon atom, we have this ethyl attachment. Remember, this is 1 and what? 2. So 2 carbon atoms, alright, as attachment is ethyl. So having said this, the name of this structure is simply 4-ethyl. Remember, this is methyl, it starts with M. This is ethyl, it starts with E. And of course, you know in alphabetical order, E comes before M. And so this is going to be 4-ethyl, 4-methyl, hex 2-ine. That's the name of the structure. We're moving on to structure number 2. In structure number 2, we've got this on the board. And if you look at this structure, I could see 2 unsaturated bonds. You see, double bond and triple bond are referred to as unsaturated bonds. And of course, they are the 2 unsaturated bonds we have when dealing with organic chemistry. Single bond is saturated. Now, when I look at this structure and say, wow, this thing is complex. Because of course, you have double bond functional group there. Alright, that is alkane functional group, double bond. And we have alkyne functional group, triple bond. Don't you worry, okay? I am right beside you to guide you. We're going to do this together. Are you following, right? Now, the first thing you should know is, out of these 2 bonds, which are unsaturated, double and triple, which one is more reactive? Because the most reactive functional group, right, is usually taken as the main functional group or the active functional group. Are you following, right? In a given structure. So in this case, we have double and triple bond. And so I'm going to tell you this. Take note. Triple bond is more reactive than double bond. Therefore, this structure, if we're given the IUPAC nomenclature, it's going to end with "-ine", not "-ine". However, in determining the longest carbon chain, you must ensure that you count to include the double bond and the what? Triple bond. And again, when you are given the name of this structure, assume that you've gotten the longest chain, so you know the name of the parent. The name of the parent will be given in such a way to respect that there is an alkene functional group there, which is double bond, and there is an alkyne functional group, which is triple bond. So what does that tell us? You don't have to take your mind back to what I taught you under alkene, the way you give the parent name. Like I stated, you have to break the prefix from the word suffix and indicate the carbon atom, the position of the carbon atom bearing that unsaturated bond. So you will do that for this double bond and again for this triple bond, which means that the parent name here will bear "-ine" to respect this, and it will also bear "-ine" to respect this. However, "-ine" will end it to tell us that, okay, the more reactive functional group here is the what? The triple bond. Alright, so having said this, I think we are set to analyze the structure. Now, if you look at this structure, first we're going to determine where we'll start our counting from. Since triple bond is more reactive than double bond, and I've told you the parent name would respect ending with the triple bond functional group. Of course, having that suffix "-ine". It means that the direction of starting our counting will be determined by this triple bond. And clearly the triple bond is closer to the right than it is to the left. The longest carbon chain you are seeing here clearly is this straight chain, or you can go this way or this way. The choice is yours. This time around, I'll take the straight chain as being longer. So let us find out how many carbons we have there. 1, 2, 3, 4, 5, 6, and what? 7. Now on the third carbon atom, I have this triple bond. On the fifth carbon atom, I have this double bond. Remember the rule. The position of the carbon atom that is bearing this unsaturated bond, double or triple, is that carbon you count immediately after which you see the unsaturated bond. I stated that under alkenes, alright, when I taught that. Now, our attachment is seen on the second carbon atoms, and of course there are 2 of them, this and this. Both of them, okay, are methyl attachment. I guess we are done. The longest chain is 7, as I said. So however you name this, the prefix is going to be het. But remember, you respect that there is a double bond there. So you have het something in. And you also respect that the parent name will end in "-ine". So it's going to be something "-ine". The something there is the position of the carbon atom bearing this unsaturated bond. So let us go. 2,2-dimethyl, and then het 5-ene 3-ine. Once again, 2,2-dimethyl. The longest carbon chain is 7, giving us the prefix het. The double bond is on the 5th carbon atom, which will now be 5-ene. And then the triple bond on the 3rd carbon atom, which will now be what? 3-ine. So that's how we analyze the structure. Is that okay? We go 2,2-dimethyl, het 5-ene 3-ine. Correct. So we are done with this structure number 2. And of course, we'll be kicking further into our 3rd structure. Quite interesting, isn't it, sir? But remember, you have to take the class on alkenes. So go through the GMAS 41 YouTube channel. You see the video lesson on alkenes. Remember, I'll have a playlist specifically for organic chemistry, and so for you to easily get to see the video lesson on alkenes, you can go through the GMAS 41's organic chemistry playlist. All right, let's go further to our 3rd structure. And as we look at our 3rd structure, this is clearly an alkyne. Because of course the functional group triple bond is there, indicating that this structure is an alkyne. We have this triple bond. We have another triple bond here. Good. 2 of the triple bonds. So clearly, however we name this, it will end in diine. Think under alkenes, we treated a structure similar to this, where we had 2 double bonds in the structure, and it ended with what? Diene. Alright, now having said this, let us look into this structure and then determine the longest carbon chain, which of course you know as you count, or you try to determine the longest carbon chain, it must include all the triple bonds. Just very close to the 1st carbon atom from this end, you see that we have this triple bond. This is carbon number 1, and then after that we have this triple bond. Now, the direction we are to go here will be something like this. Because of course, if you look at this triple bond, I think this one is closest to this end. If you check this and say, maybe let me start counting from here, 1, 2, 3, 4, 5. It's on the 5th carbon atom that you will see that. So I think this one helps to determine where we'll start counting from. If you even check the lowest sum, considering the 2 triple bonds, from this direction will give you the lowest sum to the triple bonds, because we'll have it on carbon number 1 and carbon number 5. This is 2, 3, 4, 5. After the 5th carbon atom here, you see another triple bond. If you add 1 and 6, 1 and 5, if you add 1 and 5, you will get 6 as the sum. But starting from here, we've already checked this is carbon number 5. So on the 5th carbon atom, you have the triple bond. If you continue, 6, 7, 8, 9. On the 9th carbon atom, you have the triple bond. So 5 plus 9 will give us 14. So clearly, the lowest sum is from this end. Alright, having identified the carbon atoms bearing our triple bond, and of course, from what I've done so far, you would agree with me that the longest chain contains 10 carbons. Quickly, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The prefix for 10 carbon atoms is dec. Dec, number 10. We've treated this under alkanes already. Once again, the video lesson is here in this channel at GMAS 41. Go through the playlist of organic chemistry, and of course, you will see the video lesson on alkanes. From there, you can memorize the first 10 members, like I said. It is the same for other homologs. The only difference is just the change in their suffix. For alkanes, it ended with "-ine". Alkenes ended with "-ine". And now we are treating alkynes, and we are ending with what? "-ine". Alright, 10 carbon atom prefix will be dec. So of course, you know already this will be dec 1,5-diene as the parent chain. Okay, now this is an attachment an attachment, and of course you can see that the attachment is on the 4th carbon atom. This whole unit, look at this whole thing, is an attachment on the 3rd carbon atom. When you come here, this is also an attachment on the 7th carbon atom, and we've got this as also an attachment on the 9th carbon atom. This is carbon atom number 10. So let me just write it for you to see that we have 10 carbons. So we are done with this. We can now, let's look at something on this attachment, okay, this unit. Now, this carbon is directly linked to this parent carbon. And of course, you know, on the basis of that, I would come to this carbon directly linked to this. Since this unit is an attachment, I'm going to label this carbon as number 1. And then from this carbon number 1, I will decide the longest chain. Are you following, right? In this side chain substituent. And of course, I can go as 1, 2. If I go in this direction, this becomes an attachment. Or I can go as 1, 2 in counting the longest carbon attachment here. So in either way I check, I have 2 carbon atoms as a substituent directly on carbon atom number 3. Let me take this one as the 2nd carbon. So that makes this CH3 automatically a substituent on this side chain. Then this OH, of course, is another attachment. Now, do you see that because from this carbon atom directly linked to this parent carbon, we have branches away from it. Are you following, right? This part is actually substituent on substituent. Because if you go 1, 2, 2 carbon atoms, ethyl, attached to the parent carbon number 3. On these 2 carbon atoms, on the 1st carbon, we have CH3 methyl attachment, and on that same 1st carbon, we have OH attachment, that is hydroxyl attachment. So of course, this unit is attachment on an attachment or substituent on substituent. Alright, like I said, if you are to deal with this, the name of this side chain, this is 1 hydroxyl, 1 methyl, ethyl. Let me just indicate it here. 1 hydroxyl, 1 methyl ethyl. Good. And of course, you know that this will be put in parentheses when you are writing the nomenclature. Alright, we are moving on, please. Think this is just the significant thing here. You want to pay attention to. The other ones are just simple stops, okay, for you friends. So on the 4th carbon atom here, we have methyl. This is methyl. On that same 4th carbon atom. Then on the 9th carbon atom, we have another methyl. So of course, that will be 4,4,9 trimethyl. On the 7th carbon atom, we've got hydroxyl attachment. Alright, so I think having identified all these attachments, the next thing is place the attachment in the naming and then conclude with dec 15-ine. Where do we start from first? This is hydroxyl, so it will come first. So we have 7 hydroxyl. These are methyl attachments. This attachment you're seeing here is hydroxyl and then methyl ethyl. Hydroxyl comes first, you know that, if you compare this H with this methyl. But this hydroxyl will come before this one. Because this is not just hydroxyl, this is hydroxyl methyl ethyl. If I give you a dictionary to check hydroxyl and then hydroxyl methyl ethyl for me, you will find this first. So I think the order will be this first, followed by this, and we'll conclude with methyl. So once again, what's the name of the structure? We say this is 7 hydroxyl, 3 open bracket, 1 hydroxyl, 1 methyl ethyl, 4,4,9 trimethyl dec 1,5-diene. That's the name of this structure. So let's go. Dec 1,5, I've said that before. On the 1st carbon atom, you have this triple bond. On the 5th carbon atom, you still have the triple bond. So this is how we handle this structure. Is that okay? Very interesting and fun. We shall be moving on to structure number 4. And that will be our last structure for this class. Given our structure number 4, which of course is the last structure for the class, IUPAC Nomenclature of alkynes. We observe clearly that this is an alkyne because you can see with me this triple bond, which is the functional group for identifying alkynes. Now let us look out for the longest carbon chain. And from observation, we have this to be the longest chain. If we're going this way, of course, you have to count to include the triple bond. But on this carbon atom, you can either come this way to check if this is the longest, or you can go this way to check if this is the longest. Let's find out. 1, 2, 3, 4, 5, 6, 7. This is carbon number 6, this is carbon number 7. What if we go this way? This is carbon number 6. Take note please, this is C2H5. So there are two carbon links here. Are you following right? It's just like having something of this kind. Carbon, carbon, and then 5 hydrogens distributed around them. It's still the same as writing, or we can say CH2 and then CH3. Okay, so this is a continuation of the chain, and there are two carbons here. So if we have this as number 6, then this will be 7 and what? 8. So the longest chain is this straight chain, not this one. Take note, this is 7 and this is 8. Having said this, we see clearly that this is an attachment, and this is also what? An attachment. Now, this structure, from what I'm observing, is quite interesting because I think here we are going to have this problem of not knowing where to count from if we decide to consider where this triple bond is closer to. Are you following right? Because checking from here, 1, 2, 3, 4, on the fourth carbon atom you see the triple bond. Counting from this end, 1, 2, 3, 4. On the fourth carbon atom, you still have the triple bond. And good enough, we've made something like this under alkenes. Alright? But there is still one difference you're going to see here. This difference is very significant because under alkenes, what we met there, we were able to avoid the problem, the challenge that was posed to us by that bond there being symmetrically placed. We were able to avoid that danger by considering the side we had more attachment. If you've taken that video, let's say, you will understand what I've just said. In this case, we have a lot of problem here because if we now find out, yes, the triple bond is symmetrically placed. Yes, it divides the structure into two equal parts. So one can say, okay, you can either count from the left or count from the right. But of course, you can't do that here because we have attachments. The fact that we have this attachment, we must now go further to use, alright, where we cite the attachment first to determine where to count from. Remember, the rule of where the triple bond functional group is closest to has failed here. If these attachments were not there, then we can say, fine, count from anywhere, and you'll be correct. But with the attachment there, you can't count from anywhere in this case. You now have to move on to see, where did you cite your attachment first? Sadly, if I count from here, 1, 2, 3, on the third carbon atom, you see your attachment. And again, sadly, if you count from this right hand side, 1, 2, 3, still on the third carbon atom from that end, you have an attachment there. Which means you cited your attachment first on the third carbon atom, counting from the left. And again, on the third carbon atom, counting from the right. This is such a challenging structure, isn't it? But like I said, don't worry, the GMAS 41 is always right beside you. And I am going to tell you what to do. Now that where you cite your attachment first has failed, that rule, even if you check for lowest sum, you will notice that in any direction, you will still get the same number. For example, 3, 4, 5, 6. So on the third and on the sixth carbon atom, you have attachment. 3 plus 6 is 9. Checking from here, on the third, 4, 5, 6, and on the sixth again, you still get 3 plus 6, which is 9. So in either way, the sum you would get is 9, 9. None of them is lowest sum. Alright, I think I've taught much on this. Let us now hit the point. For a case like this, you are now going to use alphabetical order to determine where you will start your counting from. Are you following right? You're going to use alphabetical order to determine where you would start your counting from. For this is ethyl. Are you following right? And this one is what? Methyl. Therefore, counting will start from the left because in alphabetical order, E comes before what? N. Is that clear? E comes before N. Another thing I've just noticed here again, just to point it passively, is that where you have more of the carbon atoms, because here we have 2 carbon atoms as attachment, but here we have what? 1 carbon atom as attachment. Therefore, counting will start from this end where we have more carbon atom, because this is weighty. Alright, the molecular weight here is more than the molecular weight of this CH3. So having said that, our counting will start from here. 1, 2, and then we've got these 3, 4, 5, 6, 7, and 8. Remember, 7 and 8 is in that C2. So on the 3rd carbon atom we have ethyl attachment. On the 6th carbon atom we have methyl attachment. E comes before M. So the nomenclature of this is simply 3 ethyl, 6 methyl. Longest carbon chain is 8. So this is oct 4-ine. 3 ethyl, 6 methyl, then the parent chain. Oct 4-ine. So this is how we handle this structure, and that's the IUPAC nomenclature. 3 ethyl, 6 methyl, oct 4-ine. And this is how we've come to the end of the class on alkynes, the IUPAC nomenclature of alkynes. Did you learn anything at all? And I want to believe that you enjoyed this class. If this class helped you in any way at all, please subscribe to the GMAS 41's channel, and we appeal to you to also inform other friends of yours. Invite them also to subscribe to our channel. Like I've always said, there are a lot more to learn. Remember, it's not only organic chemistry that we deal with here from GMAS 41. We spread out. Are you following, right, to other courses or subjects? Our playlist will give you more information of the things we cover. I'll be seeing you in our next class. Come prepared, because we shall be dealing with IUPAC nomenclature of alkanols. And it's interesting to state that we'll be moving on to another dimension of IUPAC nomenclature. Remember, for alkene, alkyne, we said something you break at alk and in or ine. Then place the carbon atoms bearing the functional group. And of course, for alkanes, we just went straight on. That one, there was not much issue. We'll be moving to a different dimension of how the parent name should be like. You wouldn't want to miss that class. So subscribe so that once I upload the content, you will be personally notified. And of course, to be notified, you have to turn on the notification bell after subscribing. See you in our next class, and do have a wonderful time. If you have any question, remember to use the comment section. Post a question there, and I'll be right there to answer your question.